All right, class, today we're going to be studying section 5.5, properties and laws of logarithms. We are going to be able to use the laws of logarithms to simplify statements. The first law of logarithms we need to be aware of is the product law of logs. The product law of logs states that if you are multiplying two numbers inside of a logarithm, it is equivalent to if you were to add the logarithm of the first number to the logarithm of the second number. It comes from our exponential rules. So if I were to go through with the log base 10 of v times w equals some power, I have to think to myself, 10 to what power has to give me v times w. Remember, whenever I multiply numbers with like bases, I add the powers. So whatever I do here, I'm going to be adding the powers together. And that's where this adding comes from. The property holds true with all types of logarithms, so a logarithm with any base, or even an ln, a logarithm with a base of e. So when I tell you, or when you see the directions expand the log or expand the logarithm, I want you to express the multiplication as the sum of the two logarithms. So it would be the log of 2 plus the log of x. If you could simplify anything, you should, but in this case we can't. You can even apply it to three terms, the ln of x plus the ln of y plus the ln of z. And that would be your logarithm expanded. The next logarithm is a quotient law of logs. And the quotient law of logs says that when you are dividing inside the logarithm, it is equivalent to subtracting the log of the numerator minus the log of the denominator. So notice, the numerator comes first, and you subtract the denominator. Let's apply that to a situation. Expand the logarithm. So in this case, I'm going to say the log of x minus the log of 4. And again, if I could simplify either of these logarithms, I should. But in this case, I can't. In the next one, I have the log of 32 minus the log of y. Notice in each one of these examples, the numerator has to come first. The next law would be the power law of logs, and the power law says that if you have a logarithm, if you're taking the logarithm of a number that's being raised to a power, you can bring the power out front and multiply it to the logarithm. Again, that comes from the fact that when we are taking a power to a power, we multiply the two powers together. So in this case, when I expand the logarithm, I want to bring the 4 out front and say 4 times the log of x. For this one, it's the square root of x, so I first need to express the square root as a fractional exponent, and then bring the 1/2 out. And then in my last example, again, I need to express it as a fractional exponent, bring the 3/2 out, and this would be my solution, all expanded. All right, so let's expand with several situations. Whenever you're expanding, the first thing you want to do is separate the fraction. So the first thing I'm going to say is the log base 6 of 5x cubed minus the log of y. Now I can expand the numerator part a bit further. I'll split it up and say the log base 6 of 5 plus the log base 6 of x cubed, and this log of y has not changed. Then to completely expand, I need to bring this power out. So it would be the log base 6 of 5 plus 3 times the log base 6 of x minus the log of y. And this would be my completely expanded logarithm. So there's no multiplication or division left in any of the logarithms, and all the powers have been pulled out. You can also work backwards and condense your logarithm, meaning turn it back into a situation like this. So this requires me to think backwards a little bit. The first thing you want to do is bring any powers back in the logarithm that you can. So since it's 4 times the ln of x, I want to express that as the ln of x to the 4th. Now I'll combine the adding together. So it would be the ln of 3x times x to the 4th, so that would be 3x to the 5th. Now, this entire logarithm is subtracted, which means that it is in the bottom of my fraction. And this would be in the numerator. So this would be the condensed version of the expanded form. And I could simplify this further by canceling the 3's and subtracting the exponents to say the ln of x to the 4th over y. We will stop there for today. If you have any questions, feel free to write them down, and we will talk more about expanding and condensing logarithms in class.